Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products. Hey everybody, welcome back to the Beyond the Bench show. Today we have the second part and the most fascinating series you'll listen to any week, interviewing my co-founders Justin Schneck and Daniel Spofford. And we received some feedback from our podcast producer right before jumping on this show that we got a little off the ranch last time. So we're going to try to keep it between the lines, try to stay on topic, but no guarantees. Just the ranches. What were we talking about earlier, Justin? Horse dancing?
Yeah, dressage.
So, perfect segue to staying on topic. But I wanted to dive a little deeper into what it is we're actually doing day in, day out, and less on the origin story. And maybe even give some insight into what Peridio actually is today. So jumping right into it, we talked a lot last time around Erlang, Elixir, Nerves, and our work experience together in Very, developing solutions for our customers. What was the bridge to Peridio? So once we'd proven that Elixir and Nerves could really tame the embedded chaos or ecosystem, what prompted us to take this more broadly to the market?
Justin, I think when you go into connected products, 1,000 times, 1,000 different ways, and you see all of the different requirements and scenarios and contexts that can happen in, I think that diverse exploration sort of taught us many hard-won lessons, and we started to be able to more and more, we've always had ideas of how great things could be or how we could do them differently, but living through that experience so many times sort of prepares you and sharpens those ideas and pushes some folks towards wanting to actually solve those problems. That's generally how I feel about it.
Especially in that development mode. I mean, as Bill was mentioning last time, we did spend a lot talking about our previous lives together, developing products together in the trenches together. That's almost the time when we were doing it. We were doing it remotely too, fully distributed as well, and that really energized a necessity to have high quality tooling that we could have confidence. So that it's a big pressure, especially distributed, to get the hardware out there and to start collecting feedback. Any product loop, you want to get that out there. You want to start collecting feedback, but your product or device in its infancy, usually in that stage, it's like a mess of wires. It's development boards. There might be I love our double E's used to call them whiskers, this hanging office, really delicate stuff. But you want to make sure that as you get that out into the field, feedback you can capture quickly. You can fix problems if you're distributing it to a customer so that they can do some acceptance testing. And that as well, just getting that into that for us, especially into the development cycles early, but furthermore, seeing how robust it would be ongoing as part of that, really bringing that CI/CD story to embedded, fully embracing that. 'Cause that was really part of our ethos back then too. We were really heavy into pushing proper modernized software development strategies onto the difficulties of embedded. Daniel, you really drove a lot of that effort, I think, in the organization as well. And that really also crystallized a lot of the desires that we had for what it looked like to have this system, this reliance.
Yeah, were some of the early driving features that customers, from the platform perspective, less on the device, but what were the, where were we always getting the most feedback or interest or usage early on?
Bridging kind of what both of you are saying, being distributed like that, both the organization, we belonged to, as well as distributed from the customer, really was like a multiplier of friction. There was huge benefits to it. There was a lot of ways that it made stuff better or forced higher quality, but it also multiplied pain points, and that's why it was necessary for us to lean in and try to address them. Pushing the continuous delivery and small iterations onto the hardware team, being able to recognize that if you weren't able to conveniently get other people up to speed to be able to push to push firmware to a device? Like, what was that process, and how hard was that to convey to someone over, the internet, talking to them and walking them through it? And what are that sort of stuff? Everything became more challenging, so it behooved us to try to improve it. I think some of the early friction points were visibility into what you were doing, and like trying to balance, especially early on in the development of a connected product, the ability for people to move quickly and, a little bit cowboy style. Like if you're the EE and a firmware engineer that are standing up a board for the first time, right, and you're iterating on low-level configuration or boot sequences of a device, you might do that on your desk, and then you might want the EE to try it. And how challenging is it to get them into the spot that you were, or to give them the update that you were using that early in the process? We're talking about OTA in a device, and then, okay, the EE said that they put the correct firmware onto the device, but did they really? Stuff like that. And
Yeah, man.
do you have visibility into that? You might spend a whole night debugging something that, where you thought you addressed the problem, but they're still experiencing the problem using your fix, and then you're 8 hours in and you go, you're not using my fix, and as silly or as easily dodgeable as that might sound, it is not that simple. And these things are confusing. So like the more that you can provide people a stable foundation, a convenient way to push updates, a convenient way to get that visibility, regardless of, no, this isn't a device that's ready to ship. This thing is covered in whiskers.
And that inflection point too, with like, not only have I experienced that pain firsthand, working together closely with an EE, but also, it's one of those situations that you're trying to navigate a very like diplomatic experience. Hardware tries to blame software, tries to blame hardware, and your life is all about proof. At that point, what can you prove so that you can offer a challenge to be able to push it back over to the other side and say, no, this is actually a problem in your domain. And much like to what you're saying, that source of truth, the proof, the ability to point at it and say like, no, I can see that you're running the wrong version. It would save so much time, effort, and frustration. Yeah.
What are some of the motivations around getting out of just supporting Elixir and more into embedded Linux?
I think just the diversity of the domain. Like, where are connected products relevant? Earth, everywhere, every industry, every domain, every company, every customer. Obviously there's exceptions, but I think just the wide variety of, everything from, we want an RTOS running on, the tightest set of cogs possible, all the way up to, what's hardware? I don't care. I just want to ship containers to a thing that works. And like everything in between, you start to realize that if you do want to create, if you actually want to solve this problem generally, which, that's why we're here, it has to be applicable across at least some gradient of these spaces. And as much as the tooling that we were using provided a lot of conveniences and minimized the amount of complexity that folks had to think about, especially if you were keen on Elixir, it allowed you to be extremely effective very quickly. But the moment that you started to introduce, well, yeah, but what if I have tighter COGS constraints than can run this? Or what if our application team isn't hip to Elixir? Or, anytime you started to tweak those parameters, you started to realize that you needed a more flexible solution, that we wanted a more flexible solution that could span that.
I want to clarify though that if we were given the opportunity to manage software for a device on Mars, we would take it. We're not restricted to Earth.
True. That's that small mind is Earth.
So if you're out there and you're listening and you have a project on Mars, please come talk to us. Really, yeah.
Future proof, future forward.
And we think the galaxy of devices.
Galaxy love. That's right. So that's.
And Linux versus RTOS, why Linux? More devices or RTOS? Bigger market? Maybe.
I wouldn't say it. I don't think of it as a versus. Much of what we're doing at Peridio is applicable still to RTOSs. But when you walk into that, that's like, it's just it's a narrowing. It's a constraint. Like when you walk onto a microcontroller and you walk into RTOSes, what you're capable of, even if it's possible, is there's more friction, there's more time spent, there's a little bit more effort. It's going to be a little bit more particular to the thing that you're doing. And like, all of Peridio Fleet, for example, is happy to collaborate there and still to give you like OTA capability and visibility into that. Like we can still support those use cases. However, Linux, yeah, is ubiquitous. It's all over the place. If you have enough power to run it, if it is within your constraints, if it matches your use case, and billions of devices say yes, it does, it is extremely convenient. You're gonna move orders of magnitude faster in certain problem spaces there than if you had to write it on bare metal. If people don't use bare metal just because some people use it because it's fun, but typically you are operating in that space because you have requirements that push you into that space if you're being responsible about it.
No, I do. Usually that trade-off of convenience, being in a higher level programming domain that you get from embedded Linux, does come with the complexity of systems engineering design. And I think that's really like, personally for me, like where the juicy problems are. And that while RTOS-based embedded microcontroller systems have their own levels of complexity, usually the frameworks and the rails that you're inside of there with the RTOS is more narrow, and there's not like a lot of ancillary involved projects, drivers and things of that nature that you much like you'd encounter in designing products on an embedded Linux platform.
Yeah, much of those, maybe a little ironically, much of the conveniences of Linux in that comparison bring complexity with respect to what you're trying to achieve. With a connected device, you want it to be, in many cases, you require it to be, secure and efficient, and for problems and solutions to be reproducible and reliable, and for you to be able to speak authoritatively about what's running on it before and after updates. And all of these things that we want to take for granted are complicated, ironically, by the conveniences. Well, can't I just like apt install something? Can't I just like SCP this onto a device? You can, but you're gonna have a bad time. There's trade-offs that come to that. And how do I benefit from the conveniences of it while still getting the guarantees that I require? And can that be easy? That's what we're trying to do.
Justin, we talked a lot about your experience in open source and Elixir in general, and it's been really interesting to be a part of that evolution and opinion over the last few years. And what have you seen specifically come about in the Linux ecosystem that you're excited to bring forward into Avocado OS, which is our base distribution?
That's a great question. I think that there's just a lot. We talked earlier about adoption of even modernized software development practices into embedded concepts, like even testing and CI/CD involvement are still sort of almost not foreign, but like less ubiquitous in this domain. Similarly, I think though that like there's things that come from the acceleration of tools available to us for software design that were very much so geared for web technologies or like server maintenance in mind. That in ways like solve some problems, but introduce once again more frictions in that case. An example here I usually point out is containers, and that there's a place in embedded Linux products where leveraging something like a runtime for a container it could be the right move for the job. And usually we see these in like more generalizable products, gateways, things like that, industrial gateways and stuff. But as you dig deeper into building specialized embedded products that really have single purposes, they're like they're going to be using specialized chips to be able to accelerate things. They need to be more power efficient. They need to be more performant for the watt. That all of these complications and abstractions and such start to fall apart
Like in order to be closer to that metal, you need to have a pretty intimate relationship with your code, with the kernel. And right there, that falls apart with the Docker and containerized experiences. They don't care about the kernel, and that's fine. But you find yourself undoing a lot of seatbelts to let the container have access privilegedly to the host that it's running on, just undoing a lot of the benefit. Now, it solved an interesting gap, which was that the pain point was that developers wanted a way to be able to conveniently have control over expressing and packaging the dependencies that their more complicated applications needed in order to get that onto the device. And I think that if we can focus on that bit right there, which is empowering developers to move in an agile way with familiar technology approaches to like building containers, so you can they have control still over the specifying their dependencies, but without exposing them to the complications of embedded build systems like Yocto or Buildroot, that they would be able to be more productive. And that's really part of a pillar of ethos that we have in designing Avocado OS. We're designing tools as part of the developer experience that embrace that same feeling, such that you can at build time pull from binary packages that we pre-built and have a means of being able to easily prepare and package your code for your runtime in normal CI/CD servers and approaches, and allowing you to be able to then compose a runtime that would contain your code and quickly boot for a variety of popular embedded targets that we're going after, right? So that right there, I think, is like the most exciting part, because it's really going to empower developers and teams to scale and move quickly.
So talk to me about the standard composition of like a robust embedded team. So I think there's like a lot of times you have like the one embedded developer, single dev project. I don't think that's necessarily where Peridio is going to thrive, but larger companies, more disciplines, what does it look like when you're actually trying to take AI to the edge, for instance?
But yeah, we've seen the team's diversity grow in discipline over the years, introducing the need for people who have deep knowledge in how these machine learning models work, and is still interrupting with high quality software engineering talent, including in some cases, out of necessity, deep systems engineers or integrators, hardware folk, front end designers, and quality assurance individuals. There's a wide variety of people that have grown across the area. It's become more like closer akin to shipping complex hardware just on embedded products. And with that diversity of teams, we traditionally in the past would approach developing a product such that everybody would sort of submit their code to the systems integrator on staff or an integration pipeline, and they'd have to wait for a long build process to occur, or there would only be certain days when they would make builds, even further complicating things. Usually, if something were to go wrong with the build, the people who have the most amount of knowledge on how to fix the problem are the application developers, but the integrator is the one that's trying to integrate it, and it becomes confusing on like getting that solved in a quick way, and that's really where that bottleneck comes into place. Like it would slow down teams and performance, and so the complications of introducing more personas into the mix and scaling out more teams to be able to handle things like data science, machine learning, and what edge AI and embedded AI has done is accelerate this need to be able to eliminate the bottleneck and compose systems in a way where they can all contribute their code similarly to like how you do it with containers. Everybody has their own isolated layers, but instead of isolation, we're going to focus on integration and make it so that the end result is this composition of a root file system that's deterministic, it's reproducible, it checks all the boxes that are desired for embedded products, because those are the guarantees that you want.
So Daniel, I think you probably lived a lot of this life while at Very as well, and there's quite a bit of thick skin on this team as these folks are the ones that were tackling the long poles in the tent. What did it feel like doing some of these embedded products, on quick timelines? I mean, were you focusing on domain logic, or were you focusing more on embedded hard necessity things?
It was challenging. To be frank, it was very challenging. I think that the reality of many projects and many companies is you're trying to get as far as you can. You're trying to drive as far as you can on very little gas. It's not like a negative mindset. It's just, there's limited time, there's limited people, there's limited money. There are constraints that we're all operating in, and yet folks want to achieve things. I found myself having to navigate, I would consider, a very extreme gradient of domains, where I am writing APIs and front ends and back ends and cloud infrastructure that things integrate with, while in the same breath going through build root menus to enable kernel extensions for the capability needed on the device to take that operation to send it up to the cloud. So for me in particular, a lot of that felt it was just challenging to navigate that context switch. It's massive context switch of, if the team is small enough, folks have to take on more. And when you operate in a space of connected products, like that more is gigantic, and it's very painful. So whether it's like an individual in that scenario, or whether you have, even when you get a more convenient setup, like when you have a team helping you, even then you bump into like what Justin was talking about, where, okay, sure, we have 2 people, we have 5 people, we have 7 people. So great, it's not so much pressure on one individual, but how convenient is it and how defined is it for them to collaborate? Even though you have the multiple bodies, how can they effectively collaborate together? Is that a pattern that you have to figure out in the moment? Do your tools kind of light the way for you to achieve that, or not? Much of my life, it was not well lit. But the benefit of that was, if you walk through your basement in the dark enough times, okay, you stop stubbing your toes, you learn things, you gain opinions about like maybe the furniture you bought. The analogy here being that, a lot of that experience is what informed my understanding of where pain is and how it could be addressed, and how we could fold that into Peridio to help solve those problems.
One thing that was always tough and a past life of mine, and I've spent less time on the keyboard than both of you guys. I'm a professional podcaster. No, kidding. But less time in the embedded world than either of you by a long shot. But when I was in school and we were writing a lot of solvers for computational stuff, you would have these horrific feedback loops. And so you'd like kick off a solve and you'd come back, like I'd literally like go to lunch and my computer would still be running. And I think that's a lot of the challenges with the Octo and build systems today, is that feedback loop. And it's also even more exaggerated when you have another person in the loop. Maybe you're trying to get something to your electrical engineer. You kick off a 3-hour build and then you get them the file and then they don't do the right one. They don't pick the right file. And so like you have this communication piece and all of these things coincide to something that is incredibly frustrating to a development experience. Folks who are fully optimized around optimizing things. They're just like, that is their North Star, is like, how quickly can we make these feedback loops? Justin, looking forward to Avocado, what are some of the like primitives that you're building into the platform to make that more possible, make this more readily accessible, and to really optimize this development experience?
Oh, man. Yeah. Speak to the heart on that one. One of the first things is that making it so that the act of using Avocado doesn't require a computer that heats your office while you're working.
Broke that computer last week, didn't we?
Yes. Yeah. Blew the radiator on it. It's liquid cooled. Like using Octo, if you're doing a full rebuild, even on the most powerful machines, is a much different magnitude of satisfaction loop than traditional just desktop software. Lastly, if you're not virtualizing things and you really need to integrate, you're tethered to some piece of hardware as well. That's a first primary step with the binary distribution of things. We want to make that loop faster and make it more portable so that you can build on infrastructure like GitHub, GitLab, CI/CD stuff, Circle CI, wherever you might be, without breaking the bank. And that'll increase productivity quickly. But the other thing too is, hardware in the loop has been a term that's in the industry forever about developing on hardware. You want to have it connected so that your feedback loop can be as tight as possible. And Yacho did make progress in this domain. They've had some articles, they've had a lot of talks that people would give about the way that you can use in Linux network file systems, NFS, to mount your root file system over the network so that your build machine, still producing things incrementally, can affect a served directory that the target that you're connected with is over the network using as its root file system. It's very cool stuff, but it was also very complicated to be able to get set up. We have a good friend and co-author of the Avocado work with us and here at Peridio as well, Frank Vasquez, who was previously on, also brilliant person, wrote the book on it. And there's some thick, meaty sections to that book that talk about how to get the NFS stuff running. Even the brightest people, when you re-engage with these tools, it takes a while. And so we're also looking to be able to satisfy that part of it, make it much easier to be able to use that kind of tools, and not as clunky as mapping your entire root file system over, because when that goes wrong, it fails early enough that you don't get pleasant warnings or errors or help in debugging that situation. We want to make sure that the system can like really give you, present you with good feedback and when something would go wrong, but also give you that tight integrated development loop, right? And so once we make that tool nicer and easier to use, I think that it will be even more accessible to individuals to do that kind of stuff.
Finding sanity and having a solid foundation to rely on and iterating quickly are all things like the line of questioning you were hitting me with before, Bill. That is like where I ran to in those scenarios, to make my way out of it, was like, well, what I have to get to here is a spot where I can, build a solid foundation, trust something, and then build upon it and iterate and push and iterate and push quickly. Yeah, like we were saying before, it's one thing to like be able to do those things at all. It's another thing for the tooling to make that fast and convenient and help you achieve that. And that's where Avocado has been pivotal in pushing that forward.
You've had the joy, though, at least, of being like, I'm going to go over and do some of the web stuff for a while just to get that serotonin kicking again.
Why is it so hard? Why is this the right time for us to spend our precious time working on this problem? Why is this unsolved in the market today? Why are we at a moment where this is worth taking a crack at?
I think it requires a couple of different things that are hard to get into the same room with alignment and funding and like desire to push on it. It requires like the perspective that was achieved by seeing so many different products in so many different domains, and how you can look at 13 different things, and if you look at them just right, hey, it's the same picture, and you can start to see how solutions are relevant to all of them and where the good abstraction is. That is very challenging. It is hard to do that. It's easy to point at problems, but it's a whole different thing to see the problem 100 times and come up with a good solution that is actually achievable and fits all of them. So you need perspective, you need capability. We have a very talented team. We're lucky to work with the people that we do, and their ability to explore ideas and fail 100 times just to find the 101st that works is necessary. I think it's also the world changing and evolving around us. We talk about heterogeneous architecture and the wave of AI and robotics and the commonality now of hardware of single products having many different processors and specialized processors and ASICs and all of these things, and wanting to manage that. Those things blowing up in popularity. So it's not just 13 of them in cool places, but people wanting to make hundreds of thousands of them and reliably keep them up to date. So it's both like the the perspective, the capability, and then the world changing around, like driving more and more desire and more friction around not having a solution here. Those I don't know. Those are the things that like come to mind that sort of inform the why now.
For sure, all of that, and even furthermore, I think I'm overwhelmingly grateful for all of the brilliant minds in the communities and the organizations that have worked so hard on building the tools that we have even today with Yocto Build Root. They made it possible to build this kind of stuff, and so that's like not a trivial feat. We do have access to tools, and even though they might in some ways still feel primitive in comparison to what we're used to with accelerated software development tooling that we might reach for in domains like web programming, that it is capable that we can finally do this stuff. And I think a late friend of mine, Joe Armstrong, creator of Erlang, had this quote where it was that you should make it work and then make it beautiful. And I think that really applies back to what we see in the embedded market. Like, we've made it work. Brilliant minds have made this work. And we just need to work to be able to make it beautiful. And similarly to how we've seen containers, Linux containers, for example, they existed long before Docker came along, but they were complicated to use. It was difficult to use them. And Docker came along and made it beautiful. And then that was ubiquitously adopted, and people really gravitated to that as a accelerant in their software practices.
Do you think Docker's beautiful?
Well, I have a comment on
More beautiful than containers.
exactly. That's such a great timed question, because I think because I love that quote, and I think a lot of times that quote needs to be carefully interpreted, because when people hear like "make it beautiful," I think a lot of times folks might errantly think that it's like gold plating or spinning your wheels on something, making it like engineers do a lot. So it's understandable why people might think that, like, putting more effort into something for very little gain or unnecessary gain. They might think that. That's not how I interpret that quote. When I hear "make it beautiful," to me, that means you go from something that like just works and just solved the problem, go to something that is like a clean abstraction and is well architected and can be used not just in a needle use case that was specific to you, but it is more generally useful. And to me, it speaks to what I was saying before of, I said you need perspective, you need capability and all of that. That exists in the world. There are people with the perspective similar to ours and the capability of ours or more. But oftentimes the make it beautiful part, oftentimes when folks walk down this path, they are walking down it incrementally, specific to their company and specific to their domain. There are services out there that, make building Linux at some company convenient. That, like, it would be foolish to think that doesn't exist. But the part that doesn't exist is the beautiful part. Like, I don't need it for company X. I don't need it for company Y. I want a solution that can be, a generally useful tool, something that can be scaled out across these domains. And not only is that like beautiful, but it makes the solution itself better. When you have a solution that's specific to one thing, if you can make it applicable, this isn't universally true, but generally, as you span it across different use cases, you're going to make it better and better. It is going to be more well architected. It forces it to navigate different domains.
How does this relate to culture?
Beauty?
Mostly thinking about what do we have this week? It wasn't the Emmys. It was there was something. No, I'm kidding. No, but how does this relate to engineering culture? So, engineers notoriously love, I brought this up, they're built to optimize things. So what's the line here between, making something beautiful, getting it done on time? Like, how do we carry this stuff forward into Peridio as far as like managing our day in, day out work?
I think that it's really, I kind of see it as like a prescriptive book downwards in that case. Like, to the engineers who spin out on that point, make it work. And then when you enter the make it beautiful phase as a product person, that means you get to start enjoying like more widespread use cases and adoption, to Daniel's point as well. And so I think it, what we tend to see as engineers that want to make it beautiful first, but never really end up getting it to work because they end up spitting out too much on bike shedding the color, right? And then in this case, like it's really, I think, culturally driving the desire to say like, yeah, we want to be able to have sustainability. There is a balance to be struck, but first we got to be able to understand what's necessary to make this thing just work. And then we can work towards sustainability and manufacturability and all of those cases.
Yeah, and it's not it's kind of it's the, again, I interpret that quote as a little bit recursive. Like it's not make it work, period. Okay, I don't care about that anymore. Now let's make it beautiful. To me, making it beautiful is just like a recursive step in where you're like, okay, I need to make it beautiful now. Step one is make it work. What does it need to be beautiful? And now we're in the make it work phase of that, especially in in any company, but especially in one that is early like ours. You need ruthless focus on what is necessary, what to make it work. And just because you're in like the make it beautiful phase of like abstracting some solution that you have, it doesn't mean that mentality goes away. It can't go away. You always have to focus.
Yeah, it's been really interesting to watch Peridio come to life. I mean, it felt like, months and months and months of just make it work on like the platform side. I think Justin's like on that on Avocado right now, like trying to make the thing work. And I think there's beauty in mind, sure, but like V1, let's get it working. But when we finally were able to take a step back, and I think every executive ever has been like, I need dashboards, I need blinky lights, I need lines going up and down. And it was a really cool moment in our product and platform when we were able to tie all that together, because from my perspective and product perspective, like, wasn't that just as simple as a drop menu? And it's like, well, that thing is controlling 100 other things that have to be bulletproof and work. And so it is really nice to take a step back and see that the fleet product in particular, be it a beautiful, might be a little generous at times, where it works at scale. It's slick. It's helping customers. They've got lots and lots of devices on there, and if it wasn't beautiful, none of that would be happening.
I think that's the case. It's the beauty is being fed by the customer feedback. Now we're in the wonderful stage where customers that come on board, like, yeah, they have those requests, and we can really satisfy them with what's beautiful to them, and that in general like ends up being beneficial to other people. And so really now the product has entered a lovely beauty phase where we get to be able to make it beautiful for you, because we deeply appreciate and accept the feedback that we receive from people who are actually in the trenches shipping these products. We've been there ourselves, and a lot of the fuel has been put into place. And but having those conversations, gathering that feedback, and really tuning the operation to be able to satisfy those use cases is fantastic.
It highlights how those two phases feed into each other. Like I was saying before, it makes me like the phrase of like emergent beauty comes to mind, where, like you were saying, Bill, like there's a long period of time where you're just like, make it work, make it work, make it work. There's 100 things that we're doing to make it work. And when is this going to be, like, God, when can we get past that? And you if you do enough of those and you're focusing on the right things, you do wake up one day and you get to a point where it just like clicks and you're like, oh my gosh, like it is beautiful. There is this, observability that we get into it, and it just works. And it's efficient and convenient and powerful. And it wasn't like that was because 4 days before we finally pointed the team at the beautiful task in backlog.
Yeah.
It's arising out of all of that effort comes that. So that's, it's extremely satisfying to also have our customers, voice that back to us. I have a lot of conversations where folks are like, hey, we noticed X, Y, or Z thing because we were able to have that visibility into what our devices were doing from Fleet View. And that's, and I sit there and I'm like, great, I'm so happy for you. And I'm like, yeah, thank God. That's the point. That's what we've been working so hard on is exactly that. So it's extremely satisfying.
It's interesting. Product development is hard. Digital product development is hard. Creating tools is hard. And I don't think what we're doing is nearly as hard as building and scaling hardware products.
Yeah.
And I think that's important to keep in mind as we serve our customers, and that they are they are living life on the edge in a very, real way, and they're scaling to tens and thousands of devices. And this observability tools, remote access, it's key, and it's very important for them to have all that in place and to be reliable, because what they're doing is frankly impossible. They're like beating the odds, like they
Real heroes.
yeah, I mean, like 9 out of 10 startups fail, but like when you add that like hardware multiplier onto it, like good God, it's tough out there. So we're lucky to be a part of this and to have, great customers that are using the tools every day. Let's talk about Summit. So Justin, Open Source Summit, what are you excited about?
There's always great vendor expo at Open Source Summit. Last time we saw some really exciting hardware that was out there. It was great to walk the floor. I'm excited for the talks. I know that Frank's going to be giving a talk, and he's going to be talking around the use of system extensions with systemd and modern compute platforms to enable some really slick debugging tools. It's also some stuff that we're working on together with Avocado OS as well. So really neat way to be able to catch some previews there. I know we'll be there with a booth, so we'll be surely talking about all of this for Avocado and Peridio in person. It'd be great to be able to get anybody who's going to be around that day also to show up. I'm super excited for those conversations. You get me in a room with smart people, and I can talk for hours and just geek out about all kinds of topics. So that's really what I'm looking forward to a lot. The socialization, the networking, seeing a lot of the real go-getter people that are doing the job, the hardware problems. So
And Daniel, you're excited that it's in your hometown. You don't have to get on a plane. That's what's up with you, right?
Stoked.
Well, I think we'll call it there. This is a really fun conversation. I hope everybody enjoyed it. And yeah, please reach out if you're going to the summit, or if you're not, do reach out anyway. We'd love to get your hands on Avocado OS. Check out our new way to build and bundle embedded Linux distributions. We're really excited about rolling this out. And what Justin didn't say is we're making a big public release of the product and platform available in late June, like at the summit. So supporting a couple of keyboards. What targets are we supporting, Justin? What's on your work list?
we have some really good friends in the OE4T groups. We're going to be working on some of the Nvidia Jetson hardware, the Orin series stuff, some good stuff there. We've also been playing around with the new NXP Freedom boards, FRDM, the 93, the 91. Those are really cool. I love that NXP is making a single board computer now, and not just EVKs. And also got our eyes on some really slick stuff that's shipping the compute modules from Raspberry Pi, some Seed Studio hardware. That's really neat. I love those guys too. They're great design house. And also together we're looking to support some hardware from our friends at OnLogic with the compute module stuff too. So yeah, there'll be a good amount of targets coming out of the gate swinging. Eyes are also on TI, STM, looking at some stuff and MediaTek and other domains too. So, target support. If you don't see it, join us on Discord. Come say hi. Talk about the project. Tell us what you're up to. So.
Awesome. Well, thanks again, everybody. And yeah, hope you have a great day. All right, everybody, just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.